Hello, folks. Hope you have a good Monday today. I'm recording this on Saturday evening, so wish you all a good weekend. If you had a good weekend, awesome. With that, acid and bases are both electrolytes when they dissolve in water, and they get activated when they dissolve in water because the hydrogen in water makes acid what it is, and the other part of water, if you take away one hydrogen, is the OH left, makes it basic. That was the original definition for many years, and now we have improved upon it and expanded the definition to include other things that might not just have H and OH in it. However, most acid and base do have to have water to activate it because they are electrolytes solution. With that, pretty much all acid will taste sour when dissolved, and all basic substances will taste bitter. With that, you can tell there's a lot of medicine that are basic in nature, and then there are some medicine that are acidic in nature too. Both of them, once again, conduct electricity very well because they are electrolytes. Acid cause blue litmus paper to turn red, but they will also keep red litmus paper red. So just remember, acid goes to red. And then bases are blue no matter what. So bases, whether it's touching blue litmus paper or red litmus paper, will become blue. So BB and AR. Okay. Once again, acid reacts with metal to produce hydrogen gas. And so if I dissolve some calcium or some iron or some zinc in acid, you will see hydrogen gas comes out. Remember our copper lab, when we dissolved the copper in acid, the fission came out. For many years, the definition of acid is based on the concentration of the hydrogen ion, which is H plus, not H, because H is the hydrogen atom. And then bases were based on the definition of the hydroxide ion, OH negative, okay? Not HO, OH, because if you split up water, it's HOH, one side is the H and the other side is the OH. Acidic substances tend to have more hydrogen, and then basic substances tend to contain more hydroxide. Now they can contain both, but one will be more dominant and one is less. Think of it this way: I am genetically male because I have more testosterone than other hormone that would make me female. Okay. Pure water is by nature H2O only, but in water, even by itself, it does break up once in a while to become hydronium. And hydronium is just a hydrogen ion that leaves one of the water and attaches itself to another molecule. So H2O plus H becomes H3O. And hydronium is what we're going to be talking about a lot more in terms of behavior of acid, because it's not the H that actually does the characteristic behavior of acid, is actually hydronium. So once the H attached to water, it is acidic. But once again, water, when it's split up, will become hydronium, and then also hydroxide as an acid and a base. But because it's split up evenly, the number of hydronium and hydroxide are the same, water is considered neutral. So water has a pH of 7 because 7 is neutral. So the first definition of acid and base came around in the end of the 1800s. The gentleman said that acid is basically anything that has more hydrogen ion, aka hydronium ion, and then bases is anything that contain more hydroxide ion. That was just straight out the basic definition at that time. And it was incomplete, therefore we obviously have more scientists that came after him in the early 1900s that took this definition and expand upon it. But this definition, by all facts, are still absolutely correct. It's just the definition has expanded to include other chemical that doesn't have just hydronium and hydroxide. Okay, but it is true that most acids still have hydronium and most bases have hydroxide. The Bronsted-Lowry definition is the one that we're going to use most of the time for the high school level. And here we say that acid is a hydrogen ion donor because it makes hydrogen ion and it has a lot, it can donate it. So make sure you know that acid under the Bronsted-Lowry definition is a hydrogen ion donor. And base, because it has OH, which is negative, it wants to be attracted to the positive hydrogen ion or the hydronium ion. Base is a hydrogen ion acceptor. So that underlying part is the key thing, okay? So acid or hydrogen donor and bases or hydrogen acceptor. So here you can see water is acting as a base. Now, how do we know it acts as the base? And this is an acid because HCl, when it's done, is just Cl. The H has been given, so HCl has donated the hydrogen, therefore it's an acid. H2O has now become H3O. It has gained or accepted another hydrogen ion. Therefore, it is the base because it's a hydrogen ion acceptor. Here, water again acts as a completely different role. NH3 has 3H before, afterward, it has 4. So NH3 here has accepted an ion, therefore it is a base. And H2O has 2H before, afterward it only has 1H. It must have donated an H. So when you look at the before and after, or the product and the reactant, on both sides of the equation, you can clearly tell which one is an acid and which one is the base. But water can be both an acid or base depending on what is next to. So for me, for example, I can be a donor if I'm, working with other people who have less resources than me. But for sure, I can also be an acceptor because on my birthday, people can give me gifts and I can accept some of them. So just like water, any one of us at any time can be a donor or an acceptor. Water is the same way. It can accept hydrogen or donate it depending on who is next to or what it's reacting with. The word conjugate just means the version of the same substance before and after. And the only change is before it has one more hydrogen or before it has one less hydrogen. So water is H2O. Afterward, it could be OH, which has one less H, or it could be H2O, and then afterward it can be H3O plus. So the conjugate to water could be OH or H3O. So if water was, for example, an acid here, it has become a base here. So this is the conjugate base because now it has the ability as OH, which is negative, to accept another hydrogen. So OH is negative. It wants to accept the positive hydrogen. So now it's called a conjugate base. Water before here is a base. How do we know that? It gave away or it accepted. Well, it must have accepted another hydrogen to become H3O. So now the version of itself afterward will be the opposite. So it started out as a base before, now as a conjugate acid. Because now it's positive, it can afford to give away a positive hydrogen ion. So the word conjugate is the same version of the chemical before or after with one more or one less hydrogen. And it usually, or almost always, is the opposite. So an acid before becomes a base afterward, and the base before becomes an acid afterward. So here is just the additional definition I mentioned earlier. And a conjugate acid-base pair is what I demonstrated earlier, okay? So H2O can become OH, that's one conjugate acid-base pair, and then H2O can become H3O. So here are just a more graphic to show you what is the acid before, which is H2O, is now the conjugate base because it's OH. NH3 before was a base, NNH was a base. Now NNH is the conjugate acid because it has accepted when it was a base, one more H, and now it has extra H to donate. Okay. So acid or what? Think about it. Bases of what? You can have multiple words. You can say acid or sour. Bases or bitter. Acid can be hydrogen donor. Bases can be hydrogen acceptor, right? Acid more in concentration for hydronium or hydrogen ion, and bases have more concentrated with hydroxide ion. So there's multiple ways to finish this. So let's just do some example of what an acid and a base is. In this case, I have water reacting with an acid. So usually if you don't know, you can just Google which one is commonly an acid or which one is commonly a base. So this one is commonly an acid. It tends to have a little bit more H at the outside. So the hydrogen will donate to this one. And therefore, since water is accepting it as a base, so I would have CH3, COO negative, because that H at the end has left. And then I am adding to it. So H2O now becomes H3O plus. So before, the chemical was an acid, now it's a conjugate base. Before, water was the base, and now it's a conjugate acid. So you always become the opposite version afterward. As we mentioned, NH3 earlier is a base. You can Google that up, because if it has a pH above 7, it's a base. If it has a pH less than 7, it's an acid. And HCl is a very strong acid, your stomach acid. So now the H will donate here. So therefore, now I have NH4 positive, because when you gain hydrogen, you become more positive. When you lose hydrogen, you become more negative, plus Cl negative. Okay. So and H was the base before, now it's a conjugate acid. And H and Cl before was an acid. Now the Cl, which is part of HCl, is a conjugate base. Water is, because it has the ability to accept both hydrogen and donate, is known as amphoteric. So amphoteric, or any substance that can act both as an acid or a base. Kind of like the word ambidextrous. Amp in this case probably means the ability to be both. So some acid are known as mono, for one, protic, because hydrogen ion, when you think about it, is just a proton because it doesn't have the electron. So for example, HCl. Okay. And then diprotic just means that it has 2 hydrogen, so maybe H2SO4. And then tries 3. Some acid can become monoprotic from being a diprotic when it donates, and it loses an H, and they can change in many ways, but for that we don't have to worry about it for this chapter. So the last definition of acid and base is the one that is currently the most accepted for majority of application, and it just say that acid actually is an electron pair acceptor. When you think about it, now this definition, or I guess explanation for acid and base, contradict each other, because before we said acid is a hydrogen donor. When you give away a positive, that's the same thing as accepting a negative, just stating it the opposite way. And then now Lewis acid is an acceptor, but once again is accepting a negative pair of electron, which is the same exact description as the Bronsted-Lowry, where it says it's giving away a positive hydrogen, because accepting a negative is the same thing as giving away a positive. And Lewis base now is electron pair donor. So instead of accepting hydrogen as the base for the Bronsted-Lowry, the Lewis definition now saying is accepting an electron pair. So the definition technically now can expand to anything that doesn't even just have H in it. So chemical in the future, whether it's for battery or for other things, you can use this definition better, because when you think about it, the only thing that's really matter in this case is chemical becoming more stable. And the way they become more stable is the way they arrange their electrons. So the electron pair is the most important in this case. So with that, we just have a little graphic of acid now is an acceptor of electron pair, not a donor. So it's a donor of hydrogen, but it's the same thing as accepting an electron pair. There are certain chemicals that are considered anhydride, and when you dissolve them in water, they become acid or base. So a lot of sulfur trioxide gas might be in the atmosphere. When it reacts with water in the air, it becomes sulfuric acid. Barium oxide could be a mineral, and when water trips through the soil and dissolve it, the two mix together, obviously, and there's a reaction, and barium hydroxide now clearly has OH. It is now a base. Okay? So anhydrides are any chemical that when you add water to them, they become acid or base, because the chemical formula actually changes. So once again, all of the definition makes sense. This definition was a little bit narrow, so when we rewritten it in the early 1900s into Bronsted-Lowry, it became more inclusive of anything that has hydrogen in it. It doesn't have to have just OH for it to be a base. So you can have no OH and still be a base. And then now our definition has expanded even more. You don't even need to have hydrogen or OH to be an acid or a base anymore. So all three definition makes sense. It's just the Lewis one is the most inclusive of all. With that, have a good Monday and see you back on Monday when I give you the worksheet to do this. Some of you will be making up your test on Tuesday too, so be prepared for that. Have a good day.